Polynomials, real zeros, multiplicity, and the intermediate value theorem. A zero of a polynomial is an x value which makes the y value equal 0, which makes the polynomial equal 0. Let's say your zeros are 3, 5, and -2. Then that means if p is your polynomial, p of 3 is equal to 0, p of 5 is equal to 0, and p of -2 is equal to 0. So this polynomial has the points 3, 0, 5, 0, and -2, 0. It also means that if p of 3 is equal to 0, then x minus 3 is a factor, and x minus 5 is a factor, and x minus -2 would be x plus 2. That's a factor. It could be multiplied by other things. So let me just throw some constant or whatever in here. But plugging any of these numbers in will make at least one of these factors 0, which will make the whole thing 0 because you'll be multiplying by 0. So these are all equivalent statements. These all mean the same thing. If one is true, they are all true. C is a 0 of the polynomial. Would mean that when x is equal to c, that's a solution to the problem where the polynomial is equal to 0, the y value. X minus c has to be a factor of the polynomial. And c, or the point c0, would be an x-intercept of the polynomial. The intermediate value theorem states that if p is the name of a polynomial function, and p of a and p of b, so a and b are x values. So if the value when you plug a into the polynomial and the value when you plug b into the polynomial have opposite signs, one gives a positive answer, one gives a negative answer, then there has to be at least one value c that lies between a and b for which the y value, p of c, is equal to 0. In other words, if the point A, p of a, lies below the x-axis, let's say p of a is negative, and if the point B, p of b, lies on the other side of the x-axis, so it doesn't matter which one's negative and which one's positive, because a polynomial is a smooth, continuous curve. It doesn't suddenly break off and jump over to the other side. In order to get from here to here, it has to go through the x-axis at least once. It could do it more than once, but it's got to go through at least once. Therefore, there is at least one value c that lies between a and b for which the function value of c is 0. So this would be the point c0. Make sense? The multiplicity of a factor is the exponent for that factor. In other words, it tells us how many of the factors for this polynomial happen to match that factor. I think an example would help. Let's say p of x is equal to x cubed times x minus 4 squared times x plus 3. Now the zeros, when you set, there's 3 different factors. When you set these 3 factors equal to 0, you're going to get 0, x is equal to 0 when x equals 0, right? So 0 is a 0, positive 4 is a 0, and negative 3 is a 0. But x is actually 3 of the factors. We could write this as x times x times x times x minus 4 times x minus 4 times x plus 3, and that would be the same thing. So the multiplicity of 0 is 3, because it is 3 of these zeros. The multiplicity of 4 is 2. It's 2 of the zeros. And the multiplicity of negative 3 is 1. This would actually be, if we multiplied it out, our leading term, if we take the biggest term from each of these, and we can come back here to do it, our leading term is going to be x cubed times x squared. If we multiplied these out, we'd get an x squared from it, times the last x from here. There's no coefficients on any of them, so the coefficient's going to be 1, but the degree is actually going to be x to the 6th. Look here, 1, 2, 3, 4, 5, 6 x's multiplied together would give us our biggest term. So we've got an x to the 6th going on. We've got zeros at 0, 4, and negative 3, because this is a even exponent, even degree, with a positive positive coefficient. We know that the graph's going to go off like this and like this. Question is, what happens in between? If the multiplicity of a 0 is odd, any odd number, so if the multiplicity is 1, 3, 5, 7, 9, then the graph goes through the axis, the x-axis, at that 0. If the multiplicity is even, then it turns out the graph is going to be tangent to the x-axis. At that 0. It turns out that if the multiplicity is even, so if that factor is squared, then that factor is always going to be positive, and it does not change signs from one side to the other. So if we go back here, at 0, the multiplicity is 3, so we know the graph goes through the axis there. At negative 3, the multiplicity is 1, so we know the graph goes through the axis there. We know because of the end behavior, it's going to go up forever. So it's going to go through at this point. That means it's somewhere down here. At the 0, it's going to go through because the multiplicity is odd. At the 4, it's going to be tangent, so it's going to come around something like this and bounce off. That's going to give us a huge head start in getting this thing graphed.